guys, today we are going to start factoring. More specifically, we are going to look at GCF and DOTS. So GCF stands for greatest common factor and DOTS stands for difference of two squares. So first, let's take a look at GCF. When doing these problems, I want you to think of two questions. What integer divides into every term, and how many variables does each term have in common? So once you think of those two questions, then you can take them out as the greatest common factor and write down what has been left behind. Really, it's kind of like dividing. So let's take a look at number one. So number one, what divides into both integers? 3. Number two, how many variables does each term have in common? 1x. So I'm going to take that out, or I'm going to divide everything by 3x. So my 3x is my greatest common factor. It's coming up front. And when I divide that out, I'm left with x plus 3, which is my final answer. Typically, at this point in your mathematics career, everybody has seen something like this before. Now, number two has a new item that I want to highlight. You never, ever want to start a polynomial with a negative. So if it does lead with a negative, we are going to take it out like an integer. So we're going to take out a -1. Okay, so that's the only integer that divides into everything, but every single term has an a in common and a b in common. So I'm going to divide everything by -ab. So dividing by the negative will change the sign, and then taking the a and the b out will lower the power. So -ab is my greatest common factor I'm taking out. So then I'll have b minus a minus b squared. Okay, this is a really good time to pause the video and then try number 3 on your own, then press play to see how you do. All right, so number 3, question 1. What divides into everything? 7. How many x's do they common? 1. So divide everything by 7x. So you're left with x cubed minus 3x squared plus 5. That is greatest common factor. Okay, I think one of the most challenging things about greatest common factor is just remembering it exists, especially as we get into day 4 and 5 of all of this factoring. Okay, so GCF again is greatest common factor. So now shifting gears, I would like to look at difference of two squares. We like to abbreviate this as DOTS. Okay. The idea of difference is going to be really important. Sometimes teachers like to sneak in plus signs in these problems, and then difference of two squares doesn't work. Okay, so again, DOTS, difference of two squares. So let's take a look at this problem. The way that I like to attack problems that are differences of two squares is I'm going to square root both sections. So when I square root x squared, I get x. When I square root 9, I get 3. I'm going to take those two terms, add them, and subtract them in either order and call it a day. It's really that easy. Okay, so here are some very popular squares that you see often. I think pretty much everybody does really well until maybe about 13, 15. And then I also want to talk about x squared squared. When you have x squared squared, it's x to the 4th. Stay tuned on that one. So let's take a look at number 5. Square root 16x squared as well as 49. So the square root of 16x squared is 4x, and the square root of 49 is 7. Take those two terms, add them, 4x plus 7, and then subtract them, 4x minus 7. Now, if you do the adding and subtracting backwards for me, that's really okay. It's still technically a correct answer because multiplication order doesn't matter, meaning 3 times 5 is the same thing as 5 times 3. So when we look at number 6, 98 and 72 are not perfect squares. Okay, so we kind of have to regroup. So when I look at 98 and 72, I'm going to immediately think to myself, both of those are even. So then they have a greatest common factor, which is what we did in examples 1, 2, and 3. So we are going to take that 2 out. Now they don't have an x in common, but that's okay. So when I take this 2 out as a greatest common factor, 2 is going to come up front, and I'll have 49x squared minus 36. Now, those numbers, those should be ringing bells as perfect squares. So let's square root 49x squared, which gives me 7x, and 36, which gives me 6. Don't forget to drop down the 2 from the greatest common factor that we originally took out, then take 7x plus 6, or take 7x and 6, add them, and subtract them, and you're done. This is a really good time to pause the video and try number 7 on your own. Number 7, though, does have a little bit of a trick in it. So we're going to square root x to the 4th, which we get x squared, and square root 1, where we get 1. Notice that I'm not writing my answer in red. That means we're not done because it has a hidden dots. I call this a double dot. So you're going to have to do this again. So I'm going to take the x squared minus 1, square root both, where I get x and 1. So when I go to do my final answer, I drop down my x squared plus 1. Then I take x and 1, add them, and subtract them. So this time I have 3 binomials, okay? So be on the lookout for the double dot when you have powers that are even and bigger than 2. So number 8, this one's a little bit of a trick question. Did I get any of you? This one's not dots. Remember, I said we like to hide those plus signs, and there I go. There's also not a greatest common factor, so in fact, I can't do anything. So this one is prime. Prime is just math fancy talk for not factorable.